Alrighty, so momentum is not equivalent to angular momentum. In other words, you cannot add them together. So when we had linear momentum or translational momentum, we said, okay, well, we add this momentum plus that momentum, and that's my total momentum. Unfortunately, we cannot add linear and angular momentum together. That's a really common, easy mistake. And you really, really cannot do that because those are two completely different things. So I'm going to give you guys an example. So here we have a tire, and here is an arrow that's flying through the air. So a 5.5 kilogram arrow flies through the air at 20 meters per second until it hits the edge of a tire, causing it to spin. The tire has a radius of 0.3 meters, a mass of 6 kilograms, and has a frictionless axle and is at rest when it gets hit. What is the angular velocity of the tire after the arrow gets stuck in it? So to start with, we have this arrow moving horizontally and it's going to get stuck in this tire. So let me go ahead and switch to my iPad. All right. So this is what's happening here. I have this arrow coming at its velocity of 20 meters per second. It's going to get stuck in here. And once it gets stuck, then the tire and the arrow together are going to rotate together like this. Okay. But what's weird is that this arrow was moving in a straight line. So you would think, oh, I just need to worry about linear momentum, but that is not true. So I like to think of this as if this arrow was coming like this and got stuck, and I took a picture right here, I could tell you that it had a velocity of 20 meters per second, or I could calculate what it could be doing otherwise. But if this was already stuck in the tire and was rotating around like this, and I took a picture when it was right here, I would have no way of knowing, was it doing this when I took the picture or was it doing this when I took the picture? And so because of that and the idea of like when you take a picture, you don't know which way it's going, we are actually going to pretend for a moment like it was going like this, but it just happened to have a translational velocity of 20 meters per second. So we need to find our angular momentum because in this case, we have conservation of angular momentum. So I need to know the angular momentum of my arrow and the angular momentum of my tire. And so in order to do that, I'm going to need to remember what the equation for angular momentum is. So let's just focus on the arrow first. So the angular momentum of my arrow is going to be the moment of inertia of my arrow times the angular velocity of my arrow. And you're probably thinking, what on earth? Because neither of those make sense. This arrow was moving in a straight line and somehow it has a moment of inertia. But at this point, when I took this picture, I can pretend like it was actually going in a circle and all the mass of this arrow is right here on the edge. So all the mass is at a radius of 0.3 and it has a mass of 0.5 kilograms. So because all of the mass is at the big radius, I know that it's going to be like a point object. So that means my moment of inertia is going to be mr squared. And so in this case, the moment of inertia of my arrow is the mass of my arrow, which is 0.5 kilograms, times the radius of my arrow, which would be 0.3 squared. And so I can then figure out the moment of inertia of my arrow. All right, so when I multiply the zero point 0.5 times zero point 0.3 squared, I get 0.045 for my moment of inertia of my arrow. And then for the units, I just need to multiply the units together. So it's kilograms, and then the radius was meters, so that's meters squared. And so that's moment of inertia of my arrow. Then the next thing I need to do is I need to find the angular velocity of my arrow, which is weird because the arrow is not actually going in a circle, it's going in a straight line. But I'm going to pretend like it's going in a circle with a translational velocity of 20 meters per second. So I'm going to remember how angular and linear velocities compare to each other. And I'm going to remember that my velocity is equal to my angular velocity times the radius. And since I'm trying to find angular velocity, I'm going to divide both sides by r. And that means that my velocity divided by radius is equal to my angular velocity. So I just need to plug in those numbers. So I get 20 divided by my radius, which was 0.3, and I will get 66.6 going on forever as my angular velocity. So we're good there. And then what I need to do next is I want to find the moment of inertia of my tire. Even though I'm not using it quite yet, I know that I'm going to, so I'm going to just do it now. So because all the mass for this tire is on the outside rim of this tire, I know that the moment of inertia of the tire is going to be mr squared because all the mass is at a radius of r. So I need to just plug this in. So I have moment of inertia of my tire is going to be the mass of the tire, which is 6 kilograms, times the radius of the tire, which is 0.3 meters squared. And so when I multiply that out, I get 0.54 kilograms times meters squared. So I'm just multiplying my units together there. So now I have the moment of inertia of my tire. All right, so the last thing that I want to do now is put all of these things together. So I'm going to have the angular momentum of my arrow to start with, plus the angular momentum of my tire to start with. And that's going to be equal to the angular momentum of my arrow at the end, plus the angular momentum of my tire at the end. So I've already figured out my moment of inertia and my angular velocity. So I just need to plug those in here because angular momentum is just your moment of inertia times the angular velocity. So we have, here's our angular, or moment of inertia, moment of inertia of my arrow times the angular velocity of my arrow. And then my angular velocity of my tire to start with is 0. So I'm just going to add 0 here because 0 times my moment of inertia is going to be 0. And then my moment of inertia of the arrow I have is 0.045. I don't know the ending angular velocity. And then the moment of inertia of my tire, I just found out over here. So that was 0.54. And that'll be times my angular velocity of my tire. To make things a little bit less confusing, I'm going to just take out these units for the moment. All right, so I just need to multiply this stuff together. So when I multiply the 0.045 times 66.66666, I get 3. Plus 0 is just 0. And that'll be equal to, I have the 0.045 times my angular velocity of my arrow plus 0.54 times the angular velocity of a tire. At the end, I know that these two objects are moving together. So I'm just going to ignore which one's which here. And then I notice that I can actually add those together. So what I'm going to get is 0.585 times my angular velocity. So then to solve, I just need to divide both sides by 0.585. And I get an angular velocity of 5.13. And that's going to be in radians per second because it's an angular velocity. And that's my answer. So both of these together are going to be rotating at 5.13 radians per second after the arrow hits the tire. So, in conclusion for this, just kind of thinking about everything that you just learned, you have the arrow coming in a straight line, but you cannot use its normal linear momentum. You have to figure out what the equivalent angular momentum is. And so, what we did is we found the moment of inertia of it as if was going in a circle. We found the angular velocity of it using the relationship between linear and angular velocities. And then we were able to put it into a conservation of angular momentum equation here, where we had angular momentum of the arrow. This angular momentum of the tire was 0 because it was not rotating. And then afterwards, they both had angular momentum. We were able to make these two angular momentums the same so we could add them together because they were both moving with the same angular velocity because they were touching each other and moving together at the end. And then we just did a little bit of algebra to figure it out. If you have any questions, let me know.